Basic skills 6. So for this one, you will need a calculator. You need it for sure. We're going to be dealing with quite some large numbers. So starting off with number 1, it's asking what is the initial population of the following equation. So this is in the form of a times 1 plus r to the t. Right? There's our parentheses there. The reason why they're not on this paper is because the software that we use to create these don't have the parentheses, don't allow us to put the parentheses in there. But when we do have this equation in this form, a is always going to be our starting population, our initial population. So we're looking at 8999 as our answer. So that one you just pluck right out of there. Number 2, evaluate at the given number. So the function of 3 equals 9 times 0.7434 to the t power. So what we're going to have, 0.7434, and we're plugging in 3. We take our calculators, we put 9 parentheses 0.7434 close parentheses to the third power, and this gives us roughly, we want to round to 4 decimal places, so 3.6975. Number 3, we got to find the rate here. This is where it gets pretty tricky for some of us. So again, we have 3,000 times 0.763. Now remember the exponent to exponent property, we have to split these up. So 5 goes in here, t goes out here. So now simplifying this out, that 0.763 to the 5th power can be simplified. 0.763 to the 5th power is 0.2586. So this is now 3,000. 0.2586 to the t power. Okay. Remember that our formula is, so you see in the parentheses that's 1 plus r. In the parentheses, that's all 1 plus r. In the parentheses here, that's 1 plus r. So what we have to do, 0.2586, we have to subtract the 1 away. Right? So if we have 1 plus r in the parentheses, we subtract 1 away, that just leaves us with a rate. So 0.2586 minus 1 gives us roughly negative 0.7414. And that is our rate there, or negative 74.14%. Number 4, do we have exponential growth or do we have decay? So we have to do the same exact thing we did for number 3. Take it one step further and state whether it's growth or decay. So for example, number 3, we ended up with a negative for a rate, so we know that's a decay. So let's see what we end up for our rate here. Times 1.56. And remember, we want to split that 3 times t, so there's our 3 to the t power. 1.56 to the 3rd power gives us 3.7964. So simplifying this out further, 7,500 times 3.7964 to the t power. And again, remember that this is still 1 plus r. This is 1 plus r, so we still have to subtract 1. So 3.7964 minus 1 is roughly 2.7964. So looking at that, we have, that's our rate there, so we have a growth. Right, growth because our rate was positive, 2.7964. Number 5. sketch the graph of each line. So we're starting off here with a linear function, right? It's x to the first power. So our y-intercept is 2. Our rise over run, here's our rise. Here's our run. So rise 4, 1, 2, 3, 4, run 5. 1, 2, 3, 4, 5. Right there. And then we can draw our line. Okay. Now x equals -4. So this is where all the x values are going to be -4. When x equals -4, we're looking at this line here. It's a vertical line. I know the x-axis goes left and right. Right, that's the x-axis there. A lot of people think it's going to be a horizontal line. But x equals -4 is a vertical line, right? And that's because if we look at all these coordinates here, let's pick these 3 coordinates here. If we look at the x values, this is -4, comma 6. See how x equals -4? If we look at this one here, this is -4, comma 1. Right? X equals -4. This is -4, comma -5. X equals -4. So, in short, that blue line is your answer, and I'll go ahead and redraw that. X equals -4 is right there. Okay, identify the y-intercept of each. This we have practice with in a previous basic skills that we did. We had practice with this in quite a few lessons that we did. So to find y-intercept, plug 0 for x. So we're going to plug in a 0 here. We're going to plug in a 0 here. So let's see what that looks like. So it's -0 squared minus 12 times 0 minus 26. Right, standard form. That zeroes out. That zeroes out. The y-intercept is 0, comma, -26. Right, that's all that's left there. Let's look at number 8. So same way, y-intercept, we're plugging in 0. So we're going to be plugging in a 0 there. So simplifying this out, 0 plus 2, that gives us 2. So 2 squared minus 9. 2 squared is a 4 minus 9. 4 minus 9 is -5. So we plugged in 0, and we got -5. That is our y-intercept there. Number 9. If we're finding y-intercept, we're still plugging in 0. That number doesn't change. 0 minus 6 gives us -6. 0 plus 5 gives us a +5. -6 times 5 is -30. So our y-intercept here, 0, -30. Okay, number 10. Write the equation and solve for the amount of money you'll have in 6 months. So you earn $3 monthly on an initial deposit of $20. So we earn $3 monthly. We don't know how many months on an initial deposit of $20. So if we look at our formula here, y equals mx plus b. Right? So initial deposit, or the starting amount, the y-intercept, right? That's going to go for b. Right? That's our starting amount. Is going to be $20. The x is going to stay x. The y is going to equal y. And now the $3 monthly, because we don't know how many months we're talking about, that 3 is going to get the x. Right? So if we're talking about 1 month away, then we'll plug in 1 if we're talking for x. If we're talking about 2 months away, we'll plug in 2 for x. If we're talking about 10 months away, we'll plug in 10 for x. But for now, the problem is asking us for 6 months. Right? So the function of 6, so 6 months is equal to 3 times 6 plus 20. 3 times 6 gives us 18. 18 plus 20 is 38. So the function of 6, so 6 months we will have $38. And it's something you can kind of do without having a formula as well to double check it. So if you deposit $20 and then you earn $3 monthly, so that's first month will be 23, second month 26, 29, 32, 35, and 38. So double check your work.